participants who have joined in this webinar, the topic being bitumen quality for better roads, we couldn't have thought of a better speaker than Professor Prithvi Kandhal, because he is a storehouse of knowledge so far as the bitumen is concerned. Professor Prithvi, and before I hand over the floor to Professor Kandhal, I would like to just introduce him to the audience. He is presently Associate Director Emeritus, National Center for Asphalt Technology, Auburn University, Alabama, USA, which is one of the largest asphalt road technology center in the world. He served as a Chief Asphalt Road Engineer of the Pennsylvania Department of Transportation for 17 years before joining in his present assignment, published over 120 technical papers, and has co-authored the first ever test book on asphalt road technology, which is used by more than 25 US universities presently. He has drafted many standards for the Indian Road Congress, and in 2016, his first ever test book cum reference book, Bituminous Road Construction in India, was published. He's also received in 2012 Lifetime Achievement Award in Asphalt Road Technology from the International Association of Asphalt Paving Technologists during their annual banquet held in Austin, Texas, USA. Professor Prithvi Singh Kandhal will be speaking on the topic revisiting viscosity grading of paving grade bitumen in India. So over to you, Professor Kandhal.
Okay, that's okay. So you can see here the title of my talk is Revisiting Viscosity Grading for Paving Bitumen for India. Next. Before the viscosity grading, we had the penetration grading of paving bitumen both in the United States as well as India. In the US, penetration grading was adopted in 1903 by the ASTM Committee D04 on road and paving materials. It was based upon the penetration test conducted at 25 degrees Celsius, which is room temperature. Now, this reminds me, I had the privilege of chairing this ASTM committee D04, and in 2003, we celebrated the 100th anniversary of this important historical ASTM committee. Next. Here you can see the penetration equipment, which is an empirical test. And again, I would like to emphasize that we are conducting the test at room temperature, 25 degrees Celsius. Next. When the ASTM, they came out with these penetration grades at that time in 1903, 40, 50, 60, 70, 80 by 100, 120 to 150, 200 to 300. And obviously in India, we have been using 60, 70, and 80 by 100, only two grades. But the other grades were used in the US. But one thing which is important for us to see is that there is a gap between these. Can you see the arrow? Can you see this arrow? Okay. You can see the gap. There's a gap between this grade and this grade from 50 to 60. There is no penetration, but that doesn't mean that 50 to 60 penetration bitumen is no good. But these gaps have were there with intention, so that there is no problem, because we do have variability in the manufacture, we have variability in the testing. So to avoid those kind of problems, we have a gap in between every penetration. That's what we keep in mind. Next. The main disadvantage with the penetration grading is that we are measuring everything at 25 degrees Celsius. So let's say we have three bitumen, paving bitumen A, B, and C. they came from different sources, manufactured from different crude sources. In India could be Iran, Iraq, Saudi Arabia, or whatever. Now they all, let's say they all have a penetration of 65. Now here we have on x-axis we have temperature, and on y-axis we have the stiffness in terms of penetration. So let's say we have three paving bitumen, all have 65 penetration, in between the 70. So they are okay. But what about the stiffness at like 60 degrees Celsius, which is the temperature of the pavement on a hot summer day? So if I look at 60 degrees Celsius right here, I can see that paving bitumen A has a high stiffness and C has the lower stiffness. Now this paving bitumen C might give me a rutting problem. And that's what happened in the United States. The reason we went from penetration grading to viscosity grading was that some of the 60, 70 penetration bitumen were okay. And some were having all kinds of rutting problem. So that we can get at one temperature of 60 degrees Celsius. So they are equally resistant to rutting. That was the main reason that we changed over from penetration to viscosity grading. One thing which is different from Europe and other countries is that in the US, the paving bitumen is refined from different crude sources. So there's a lot of variability. And same thing in India. In India, we import from different countries. So both the countries have the same problem. That's why it was important to go to viscosity grading from penetration grading in hot climate. Next. So the rutting was one of the main problems in the United States as well as in India. Now here you can see interstate, a lot of traffic developed over the years, and rutting became one of the major problems. Next. Here you can see the rutting problem on a interstate in the United States. You can see a lot of displacement of the mix is very tender, and that was a 60-70 penetration grade bitumen, which was causing all this kind of problem. On other projects, the same 60-70 was okay. So that's why we changed over to viscosity grading. Next. So in late 1960s, the ASTM originally proposed these, let's say, 5 viscosity grade. Here is the viscosity grade. So AC5, AC stands for asphalt cement, which we don't use in India. In India, we use bitumen. So AC5 has a viscosity of 500 plus minus 20% will give us a range of 400 to 600. AC10 has a viscosity of 1000 poisons with plus minus 20% will give us a range of 800 to 1200. And AC20 is 2000 poisons plus minus 20%, 1600 to 2400, and AC40 3200 to 4800. So again, you can see here there is a gap between these viscosity grades. So there is no dispute, no problem. We don't want any overlapping. Also, we don't want these grades to be very adjacent to each other because they will create a lot of problems in implementation. So here we have a gap. Here we have a gap 1200 to 600, no bitumen, 2400 to 3200, no bitumen. So these were the grades which were originally proposed by the United States. They're all kind of double, like 5 to 10, 10 to 20, 20 to 40. Next. So here you can see here that what happened that after the ASTM originally proposed these grades, AC 10, 20, and 40, there were 4 states in the southeastern United States right here, Florida, Georgia, Alabama, Mississippi. Now, they were supposed to use AC40. In India, we will call it VG40. We didn't want to use the term AC, we just said VG, viscosity graded. So they did not want to use AC40, whereas AC20 was for most of the United States. So they said, well, the AC20 is too soft for us, and AC40 will be too hard for us and might develop cracking. So they insisted that we are going to use the AC30, which will be VG30 in India. I'm just showing this one here, that this latitude of southeastern United States, where they started to use AC30 or VG30, goes here like north of New Delhi, this latitude right here. Okay, next. Again, you can see here that the latitude right here, this is Florida here. These are the 4 states they wanted to use VG30, and that's what they did. So here the latitudes right here, this is going right here, north of Delhi. Okay, next. So then what happened is that since those 4 states insisted that they have to use, they will use only AC30, so the AS team had to revise their grades, and up to here is okay. Then AC30 was introduced. So what happened? Because AC30, now there's no overlap here between AC20 and AC30. Whenever I say AC, you just say VZ for India. So there is no overlap here, and between 30 and 40, there is a big overlap here, 3200 to 3600. So there can be a bitumen which can satisfy both AC30 or AC40 or VG30 or VG40. So this did not present any problem in the United States because no state was using AC40. So there was no overlap. This overlap became a problem in India, which I'll explain to you later on. But there was no problem in the United States because nobody was using AC40 or VG40. Next. So when I came to India back in 2002, India was using 60-70 penetration grade, and what I saw on many national highways was that some national highways rutting wasn't a problem, whereas in other national highways rutting was a problem. This was national highway where rutting is a problem. It's very difficult to take a picture of a rutted pavement, but from the stripe you can gather this was a straight stripe. Because of the lateral movement of the soft mix, you can see the stripe is going like that, you know. So this lane is rutting pretty badly, and that was happening in many of the national highways in India. Some are okay, some are not okay. Next. Yeah, next, please. Okay, here you can see there was a lot of rutting. Rutting was as much as 40 millimeter on many of the cases, you know. So this in this lane, it's being measured up to 40 millimeter. Next. Here you can see because of the rutting, this middle lane of the 6-lane highway, there are 3 lanes on this side, has to be milled off. In India, which unlike other countries, most of the heavy traffic buses and trucks apply in the middle lane, which they are not supposed to do. So that's where the problem always occurs. So in this middle lane, this rutted pavement was milled off and then replaced. Next. Yeah, here you can see a close-up of the middle lane, central lane, which was milled off. Next, please. And then the middle lane has to be replaced with a new mix. So that was pretty common in India when I came back. So, and that's where I thought that the viscosity grading is very important. Next. So here is the my journey from penetration grading to viscosity grading in India. From year 2002 to 2005, I gave lectures to the Central Road Research Institute, to the Indian Roads Congress, to National Highway Authority of India, Ministry of Road Transport and Highways, and IITs. I gave a lecture that we must change from penetration grading to viscosity grading. Everybody said it's a good idea, but nobody would do anything about it. They all agreed with me, but nobody takes the lead. So in June 2005, I was fortunate to have a contact with the 10 Janpath, which was the office of Madam Sonia Gandhi, at that time, who was remotely controlling the Prime Minister's office. So they said, no, we will take some action about what you are saying. So they requested the Ministry of Road Transport and Highways, MORTH, to do something about it. So they called a big meeting of the stakeholders, including the oil companies, and they invited me to make a presentation, which I did. And based upon that presentation, the MORTH requested the BIS, which is Bureau of Indian Standards, to revise the IS 73 standard for paving bitumen, and that was in July. And then there was a meeting of the BIS, and they approved the VG grades. They invited me as a guest, and I made a presentation at BIS, and they approved the VG grades, which I'll show to you next, in November 2005. And then in July 2006, the BIS published the IS 73 with VG grades only. So in July 2006, we changed from penetration grading to viscosity grading in India. Next. Again, I want to show you that thing again here, that in the southeastern United States, they were using already AC30, which was V30. So I thought to introduce the viscosity grading in India, let's start with the VG30. Next. So my recommendation for highways was that, observation was that AC30 or VG30 used successfully in hot southeastern United States prior to superpave. Therefore, recommend VG30 for most of India. And I thought that VG30 will generally provide satisfactory resistance to rutting, no field experience with AC40 or VG40 in the US. Again, I should reiterate that we did not use the term AC in India because asphalt cement term is not common here. So we started to call them VG grade, which is viscosity grade, but the properties are the same. Next. Next, yeah, okay. So this is what I recommended here. Viscosity grade and general applications. So I recommended for India that VG40 can be used in highly stressed areas in lieu of 30-40 penetration grade. VG30 can be used for paving in most of India in lieu of old 60-70. VG20 used for paving in cold climate, high altitude regions of North America, and VG10, which replaced 80 by 100 penetration, used for surface dressing and for paving in very cold climate. So that's what I recommended in the viscosity grading used in India. Next. So that happened in 2006. Then came a shocker in 2012. The Indian Roads Congress revised their guidelines for the design of flexible pavements. It's called IRC 37. It was revised in 2012, and I'll now talk about what the revision was and what kind of impact it had on the viscosity graded bitumen. Next. So in IRC 37, they included table of VG grade versus Resilient Modulus MR. Now the Resilient Modulus is used for structural design of bituminous pavement, especially the thickness of the bituminous pavement. Higher the Resilient Modulus, lower is the thickness of the bituminous pavement. So in that table, which they came up with that table for the first time in 2012, they said the Resilient Modulus MR of mixed with VG30 is 1,700 MPa or megapascals. The mixed with PMB is 1650. The PMB is always lower, although it has much more strength than the neat bitumen. Mixed with VG40 was 3000 MPa. So look at the difference here, VG30 and VG40. So, and they also gave a example in that revised publication that the thickness of the dense bituminous macadam, DBM, can be reduced by using VG40 in lieu of VG30. So that's what the contractors grabbed that right away, because they saw a lot of saving in using VG40 instead of VG30 because of that. Now let me tell you that the data behind all these numbers, still I have not seen that data as well. In fact, there was no, I don't know where they got the VG40 at that time, because VG40 was not even manufactured at that time. So I opposed quite much, that where are the data? But so far I have not seen any data. But the main thing was that these numbers, which led to the use of VG40. Next slide. So the fallout of IRSC 37 in 2012 was that the contractors started to use VG40 to reduce bituminous pavement thickness. That was a big attraction. No VG40 was available from refinery because there was no prior notice. In US, whenever there's some changes made in bitumen specification or grade or whatever, the industry is given at least 1 year to gear for the new grades or whatever. But in India, all of a sudden in 2012, this Indian Roads Congress publication came out and it was not available. So the contractors and other fly-by-night suppliers started to use VG30 to convert VG30 to VG40 by either a crude way of air blowing, adding polyphosphoric acid, PPA, or whatnot. Different kinds of things were being used. And I used the term at that time. I was resisting this change very much, with the Indian Roads Congress. I was member of the Flexible Pavement Committee at that time. I was very much resistant. And I called it Jugaad VG40. For those of you who don't know about the Jugaad, like a makeshift type VG40 started to appear in the market, and with the dubious quality. And that went on for a few years, and I was resisting very much at that time. Next. So because of that, the National Highway Authority of India, they had an open house on this IRC 37 design of flexible pavement, and they invited me to make a presentation because I was resisting, quite much, making a lot of hue and cry. So I recommended to immediately stop the use of Jugaad VG40, permit the refineries only which produce VG40, and I also made a case that do not base Resilient Modulus on viscosity alone. It is technically incorrect. There are 6 other mixed variables, such as amount of fines, bitumen content, airwoods, etc., which can overshadow the effect of viscosity on MR, Resilient Modulus. So that was a technically incorrect. The table which I showed you was technically incorrect, but they went ahead anyway, and they are still using it. Next. So I also recommended that to use only one Resilient Modulus of 1700 megapascals for all binder types. That was same as we were using before 2012, and is also used in the US. They also use the same one Resilient Modulus. So I said only one. Don't differentiate between VG30 and VG40 or polymer modified bitumen. I also raised the point that there are only 2 or 3 laboratories in India which can actually determine the Resilient Modulus, which is a very complex ASTM test. And then we have the problem of viscosity overlap between VG30 and VG40. And as you can see here, again, the VG30 has a range of 2400 or 3600, VG40 is 3200 to 4800 poisons. So there can be a bitumen which will satisfy both VG30 and VG40. So how can you use different Resilient Modulus for VG30 and 40? So I raised that point quite much in that open house. Next. So I just want to show you this slide, repeat the slide again, that again, VG30 is 1700 MPa, VG40 3000. Lot of difference here, and which is technically incorrect. Next. So the current situation in 2022 is that we are still living with the viscosity overlap of VG30 and VG40. So how can we use different Resilient Modulus? Even if there is no overlap, if the viscosity are very close of these, still it renders the Resilient Modulus values of no value. unreliable, impractical, resilient modulus values are being used for pavement thickness design. So so the bituminous pavements are being under designed in terms of thickness right now, and that's happening in India. We are not doing any justice to the next generation by under designing our bituminous pavement, which might develop fatigue cracking in the near future. Next. So my recommendation was that let's use VG40 bitumen because after 2012 we have used VG40 quite much on many projects, including national highways, and we have not seen any problems. And also eliminate the use of VG30 and use only VG40 instead for India's hot climate. Use of VG40, which is equivalent of PG70 minus 10, has been successful in the US now after the super pave because it has been used in Texas, California, Nevada, in the hot regions of these states with no cracking. So now we have confidence, because PG70 has been used in the US without any problem, and that's equivalent to VG40. Next slide, I will show you the equivalency. Next. So here you can see in this map here, you can see, you don't see clearly the yellow dots. These are the yellow dots here, all the yellow dots here. The yellow dots represent southeastern United States with a pavement temperature of around 70 degrees Celsius. So in these areas, we would use 70 minus 10 in the hot areas of that, although they are still using, still using like VG30 or they show this grade, PG grade in between, which is not correct. So anyway, in the southeastern United States, they are using PG70 minus 10. Next. So we can see here the equivalency grade here, viscosity grade equivalent PG grade, VG40 is equivalent to PG70. So now we have a performance history in the United States that VG40 is okay, no cracking will occur. And PG70 minus 10 has also been proposed for Oman and Pakistan, although they have not started to use that, but they did a lot of study and they came up with this, the PG70 is the grade which should be used in Oman and Pakistan. So that equivalent to VG40. Next. So here you can see it again here, that in the southeast, in this area, PG70 is being used, and this kind of comes here north of Delhi. So most of India is south of that. So we shouldn't have any problem in using VG40 for the most of India. And you can see the Oman is right here. They also came up with PG70, which is equivalent to VG40. Next. So these are the proposed viscosity grading in India. I have eliminated the VG30 here. You can see here we have VG10, VG20, VG40. VG10 used for surface dressing and recycling. In hot mix recycling, we have to use a softer grade of bitumen. VG20 used in cold climate such as northern India, like in Jammu and Kashmir, and also for recycling. VG40 used in most of India. So that's what I'm proposing. I've eliminated VG30, which is unnecessarily giving any problem. And VG40, as you'll see in the next slide, we have more confidence in VG40 now. Next. So hindsight is always better, as they say. I could have proposed VG40 for most of the India in 2005 in lieu of VG30. However, I did not want to take a risk with VG40 at that time due to lack of field experience with AC40 in the United States. There was no field experience. They were saying it might crack, So I didn't want to take that risk here. So now VG40 has proved itself in India as well as in the hot climatic region of United States, where PG70 minus 10 is used, which is equivalent to VG40. So now, better late than never. That is my thrust. Next slide. What you see here is the government is like a camel. This camel doesn't want to move. If it moves, it will move very slowly. So any change in this viscosity grading, where I'm recommending that we take out the VG30 and use VG4 for most of India, which I made a very good case for that, and we have good confidence now in VG40. So I hope somebody will take this thought forward and won't be like this camel which doesn't want to move. I would like to mention that when I was young, I'm riding this camel in Rajasthan, where I was working for the Rajasthan Public Works Department at that time. There was a very, very old time when I was young like you guys and had a lot of hair on my head. Next slide, which is the end of my presentation. And what I'm hoping is that I believe that with the changes which I'm suggesting, which is removing the VG30 and we use VG40 for most of India, and also using one resilient modulus number of 1700 for all kinds of grades of bitumen, polymer modified or different viscosity grade. So with those kind of changes, we would have better highways with increased resistance to rutting as well as increased resistance to fatigue cracking. So that's my end of my talk, and will depend upon if there's any time I can take some questions answers.
So we'll definitely like to make use of your gracious presence to be a little more educated by way of question answers. And I can see about 3 to 4 of the questions here. Before I take one of them, I would like to pose my personal question to you. We came, as you took us from specification, development, penetration grade to viscosity grade to now, even in India, there is a talk of performance grade. Now, whether how important bitumen quality is with respect to the source from which it is produced. Like you said, Jugaad for VG40. So Jugaad VG40 will have a tendency to go back to its original condition also after maybe a few days of storage and all, or under the atmospheric condition. And how do you see bitumen coming only from the refineries, then coming from sources other than refineries? And what is the practice in other countries, like especially US?
Yeah, just to compare the US, when we went to viscosity grading, from penetration grading, 50% of the crude sources in the US at that time, in late 1960s, were imported from overseas with all kinds of different kind of crudes, and we have those kind of problems. So we went to viscosity grading that time. And as I mentioned before, India, we have the same condition. We have to import about 50% of the crude right now from different countries, so they have different properties. But at least with the viscosity grade, that was the interim step where at least we have the same viscosity at 60 degrees Celsius. So at least the rutting performance will be same. We cannot talk about other properties. So because of that, as you know, the PG grade was introduced in the United States. And now from the back door, I'm still a member of the Bureau of Indian Standards. So from the back door, now we have introduced the PG grades for polymer modified bitumen, as you know already. So, and I had the privilege of developing this PG grade specification with the people from IOC. Mr. Tyagi, he used to work for Indian Oil Company, as you know. He and me developed this PG grades for polymer modified bitumen, and we are hoping that in the future this PG grade will also be adopted for unmodified bitumen. So that's my hope. In answer to your question, that when you are importing bitumen from other countries, as long as it meets all the specification requirement, in my opinion, that should be as good as you are manufacturing at IOC or other companies. although I hear different stories that sometimes it starts as a penetration grade from the countries, and then they change the label to VG30 and all that. And I cannot vouch, whether that's true or not. So I think we need a much more stringent control on the quality of bitumen coming from abroad. And unfortunately, our PWDs don't have even sometimes even their penetration equipment is not working. But to talk about viscosity, many of the companies don't have a viscometer. They are supposed to use the Canon Manning viscometer, and many of them don't have even that. So we are lacking in checking the quality of the bitumen. So in answer to your questions, we should check thoroughly. Yeah.
That's right, sir. So another question is from one Mr. Nikunj, who's asking that rutting in new road construction or major overlay is becoming a huge problem even after use of VG40 grade bitumen. What are your views on this, sir?
Well, I would like to find out what kind of problems you have. There are so many things. Bitumen is the only one ingredient. If the mixed design is bad or whatever, there are some other problems, construction problem, then there can be problem. But if the traffic is very heavy, then one is supposed to use a polymer modified bitumen. So I don't know when he says that having problems on what kind of job is problem. If it's a very heavily trafficked road, then you should use a polymer modified bitumen rather than the neat bitumen. So I don't know what kind of problem with the just medium type of traffic VG40 should work.
Yeah. Yeah, I think Mr. Nikunj has to connect with Professor Kandhal separately and discuss more in detail about the type of problem, because yes, bitumen is just one part. There could be many other aspects to the problem. Sir, another question is one from Dr. Ashutosh Mishra, who's asking that the high sulfur crudes are considered better for VG30 and VG40 bitumen production. What are your views and experiences with this different crudes? High sulfur crudes.
Can you repeat the first part?
High sulfur crudes are considered better for VG30 and VG40 bitumen production. Is it true?
High surface roots.
High sulfur containing crudes.
Oh,
high sulfur containing crudes.
High sulfur containing crudes. Yeah. Sulfur, there's a lot of studies were made in the United States when there was an Arab oil embargo in 1973. And we did a lot of experiment. In fact, I was the chairman of the Highway Research Board or Trans Research Board at that time, and we had a subcommittee on sulfur. So you can use up to 30% sulfur by weight, which is 15% by volume, to increase the stiffness of the binder. More than that is not, you will have a lot of brittleness and cracking problem. So I don't think we have any requirement of the sulfur in our specifications, but there's indirectly, if your sulfur is higher, then your softening point and your kinematic viscosity will be affected. So right now we are not looking at sulfur. Right now, sulfur you can use if you have surplus stocks of sulfur, like in the US, then you can think about using sulfur to extend the supply of bitumen, but I don't think we are at that stage right now in India. So I won't comment on sulfur, but there's a lot of work has been done on sulfur.
And somebody wants to know about your views on warm mix bitumen, the green, so-called green bitumen, which is being talked about in the field.
Yeah, it's a very good idea. Warm mix asphalt. In fact, those people who want to know about bituminous construction in India, they can buy my textbook, which I wrote in 2016, about 6 years ago, and that has several pages on warm mix asphalt. It's a very good idea to go with warm mix asphalt now. The technology is almost well established now, so we can go with that. And many projects have been completed in India as well, and so far the success has been pretty good.
Thank you very much, sir, for your insights into the bitumen. There is development of a specification and all the knowledge that you have shared with us. I'm sure the 310 plus audience who have listened to your talk would definitely like to know more about you and the knowledge that you have. They like to get some more insights onto that, so they can definitely contact directly Professor Kandhal, or they can come through us, and we will get in touch with through you to Professor Kandhal. Thank you very much, sir.
Well, thanks very much. It was nice sharing my thoughts with my colleagues here.